all to this lecture. Today I am going to explain transportation problem by northwest corner method. See here, solve the following transportation problem by northwest corner method. So this is one of the method used to identify the initial basic feasible solution for transportation problem. Here the problem is given in the matrix form. Here three factories F1, F2, F3, they are produced products. So these products are transferred or transport to the different destinations D1, D2, D3, D4. Once again, so the products are produced in these three companies. These are transported to the different destinations D1, D2, D3, D4. So here we have to calculate minimum transportation cost. First step is identify total supply and total demand. Total supply equal to 7 plus 9 plus 18. That means 7 plus 9 plus 18 equal to 34. Total demand 5 plus 8 plus 7 plus 14. So shown here, total demand equal 5 plus 8 plus 7 plus 14 equal to 34. Here total supply equal to 34. Total demand is 34. So that's why the given transportation problem is a balanced transportation problem. So iteration 1. In northwest corner method, always consider northwest corner. So according to direction, this is the north, this is the west. So northwest corner is, this is the northwest corner. In this table, always consider northwest corner. So here F1 D1 cell is northwest corner. To this cell, the demand is 5 units and supply is 7 units. So we have to allocate 5 units to this cell. After allocating 5 units to this cell, demand is 5 minus 5 equal to 0. And the supply is 7 minus 5 equal to 2. So this column is exhausted because it is satisfied. So that's why this column, D1 column, is deleted for next iteration. Once again, F1 D1 cell is, this is the F1 D1 cell. To this cell, demand is 5 units and supply is 7 units. So we have to allocate 5 units to this cell. So after allocating 5 units to this cell, here demand is 0 because 5 minus 5 is equal to 0 and supply is 7 minus 5 equal to 2. So here D1 column is deleted because it is satisfied. That means demand is 0 to this column. Next iteration 2, F1, F2, F3, D2, D3, D4 because D1 is deleted. So here also we consider northwest column, that is this column or this cell. To this cell the demand is 6 units but supply is only 2 units. So that's why we have to allocate only 2 units to this cell. So after allocation 2 units to this cell, here supply is equal to 0 because 2 minus 2 equal to 0 and demand is 6 because 8 minus 2 equal to 6. Here this row is satisfied because there is no supply to this row. So that's why this is deleted for the next iteration. Next iteration 3. So F1 is deleted. So that's why here F2, F3 destinations are D2, D3, D4. D2, D3. Listen here. Destinations are D2, D3, D4. Supply 9, 18. Demand 6, 7, 14. So consider again northwest corner. So this is the northwest corner. To this cell demand is 6 units. Supply is 9 units. That's why we have to allocate 6 units to this cell. So after allocation 6 units to this cell, demand is 0 because 6 minus 6 is equal to 0 and supply is equal to 9 minus 6 is equal to 3. So supply is 3, demand is 0. So this column, that means D2 column is deleted for next iteration. Iteration 4. After deletion of D2 column, here 2 columns D3 and D4, factors F2, F3, demand is 3, supply is 3 and 18, demand is 7 and 40. Consider northwest column. Here this is the northwest corner to this table. So here demand is 4 units but supply is only 3 units. So that's why only 3 units are allocated to this cell because only supply is 3 units. After allocation 3 units to this cell, here supply is equal to 0 because 3 minus 3 equal to 0 and demand is 7 minus 3 is equal to 4. Demand is 7 minus 3 equal to 4. So this row is exhausted or satisfied because there is no supply of factory F2. So that's why this row is deleted for next iteration. Iteration 5. Only factory F3, destination D3 and D4. Only factories F3, D3, D4. Here demand is 4 units, here 14 units. Supply is 18 units. 4 plus 14 equal to 18. Supply is 18. So here to this cell we have to allocate 4 units to this cell and remaining 14 units to this cell. Demand is 0 because 4 minus 4 is equal to 0, and 14 minus 14 equal to 0, and supply is 18 minus 18 equal to 0 because 4 plus 14 equal to 18. So that's why columns D3 column, D4 column satisfied, F3 row is satisfied. So next summary. So this is the original table. F1, F2, F3, D1, D2, D3, D4, supply, demand. So in first iteration, F1 D1. So this is the F1 D1 cell. To this cell 5 units are allocated. So 5 units are allocated to this cell. On iteration 2, F1 D2, 2 units are allocated. F1 D2, 2 units are shown here. Iteration 3, F2 D2, 6 units are allocated. F2 D2, so this is the F2 D2 cell, 6 units allocated to this cell. Next iteration 4, F2 D3, 3 units are allocated. Iteration 5, F3 D3 cell, 4 units are allocated. So which is shown here, F3 D3 4 units, and F3 D4 cell 14 units are allocated. F3 D4 14 units allocated to this cell. So after allocating all the units, finally we have to calculate minimum transportation cost. Transportation cost is equal to number of units, allocated units multiplied by unit cost in that cell. F1 D1 cell, 19 rupees is the unit cost and allocated units are 5. So total cost is equal to 19 multiplied with 5 units, 19 multiplied with 5 units plus 30 multiplied with 2 units plus 30 multiplied with 6 units, 30 multiplied with 6 units, 40 multiplied with 3 units, next 70 multiplied with 4 units, next 20 multiplied with 14 units. Total transportation cost is rupees 1015.